Hi, welcome back to Engine Shop Joe. And today I wanted to show you the results of a couple of road tests from a unit that we've been struggling with for months with problems where the drivers are complaining the hot lights on the dash all the time and the regen light on the dash is on all the time and the wanting a regen light is on the dash all the time. And so this all started about a year ago, and we had put injectors in the truck. It had like 19,000 hours. And Jake had changed the DPF about 3 months before he put injectors in it. And at the time, I didn't have a road test to look at. So it's like pulling teeth to get him to do a road test with one of these drivers. So finally, I'm going over and I'm saying, let's check this, let's check that. And they put injectors in it. It didn't help with the regen problem that much. We did injectors because when I would do a stationary regen, the exhaust outlet temperature was like 150 degrees hotter than it should have been. And it may not sound like much, but in a regen, that's a lot. So we couldn't seem to get that corrected. And I told him, I said, it's smoking. So in a regen, when you're in a stationary regen, the EGR is shut. So I wasn't worried about that. And we had the right boost. We had the right exhaust gas pressure. We didn't have any leaks on the system. So I figured, well, all that's left really is the injectors. And we had done two stationary regens in a row. Now, an engineer told me a long time ago, if you're having real trouble with one, do a stationary regen, let it finish, and then do a second stationary regen within 15 minutes. There's a reason for that. It has to do with something the software times in the ECM. So anyway, he said the second stationary regen is the one you look at, because the first one we're just cleaning stuff up in the after treatment, getting everything hot and cooked out. The second one's going to be the important one. So I did that on this unit, and I still had excessive out temperature. So we put injectors in it. And when we did the regen again, that brought the temperature down a little bit, maybe 50 degrees, but it was still 100 degrees too hot. So the DPF restriction was a little high in the regen, but it wasn't crazy. So I told Jake, I says, probably that DPF you put in there got damaged from all this smoke that's going back there. And in a nutshell, he didn't want to change it again because he has to build a customer for all this stuff, right? And he just put one in. So time goes on, and over the course of the next 9 months, we took apart the EGR sense housing and cleaned it. It had plug ports in it, so that was definitely a problem. And it had a broken exhaust bolt. We got that out, put exhaust gaskets on it, and this is all over. It comes in, we do something, and then 2 months go by, it comes in, we do something. And you got to remember the truck's got other problems it comes in for too, like suspension issues, airbags, brakes, the roll-off cable snaps. So in the course of a year, we finally get to the place where, Jake says, the driver's complaining about this all the time. And I say, I'm not helping you unless you do a road test on it and log all parameters. So I went over and I showed him how to set it up. And the driver came in, and the route they take, they leave his shop, and they drive about 3 miles down a level road, and then they go up a hill that is probably a 16% grade, about 3/4 of a mile long, and it's curvy, and then it's got some straight parts. So that's pretty much full throttle. Now the truck we're working on, talking about, is got an Eaton automatic in it. So the driver just turns, starts up the hill and floors it. And So then once they get up to the top, they go down the road a little bit, they get on the freeway, and they come down about a 5 mile downhill grade, get off the freeway, go down another grade, and then they're back to that road where he came from, and they pull in the shop. So it's about a 20-minute road test. I'm telling you all this because you're going to see some snapshots of the road test from before we did repairs and after. So now I'm going to tell you what we did. When I got the first road test, I looked at it and I noticed a couple things. The EGR differential pressure was extremely high. I'm sorry, the diesel particulate restriction was extremely high, and the EGR differential pressure was extremely low. So I knew the ports were cleaned. I knew it had new sensors on the EGR system, the sensing sensors. So I knew that wasn't the problem. So I told Jake, I said, you're going to change the EGR cooler because it's plugged. And he said, okay. And then at the same time, I said, you're going to put a DPF in it. And I don't care if it's only a year old. If you don't change the DPF, don't call me again about this truck. So he put a DPF in it. And so now they did the same exact route on the road test. And they got done, and he sent it to me, and I looked at it, and I could see significant differences in the road tests. And I said to Jake, does it run better? And I knew it did. And he said, you know, the first time we went up that, it's called Granger Road Hill. So as soon as we went up Granger Road Hill, the first time the truck labored all the way up the hill. He said the second time it scooted right up that hill. Now they go up empty, but the truck probably weighs 40,000. And the engines, this particular engine is a 500 horse with an Eaton automatic, 1,850 foot-pounds of torque. So that gives you an idea what the engine is. It's an ISX 152350. So now, I talked enough about that. Let's go and take a look at the snapshots of the road test. I'd like to be able to show you the whole road test because there's about 60 different values in it that we could look at. There's about probably 10 to 14 that pertain to what we're talking about. I just took the most critical, most important ones that would really show you the difference. And when you look at these, remember all we changed was the EGR cooler and the diesel particulate filter. Okay, let's go take a look. Okay, I'm going to put up some screen prints of the logs that we did. And here you've got the road test before the EGR cooler and DPF is replaced. Notice our percent of load was 100%. Our after treatment diesel particulate filter differential pressure is at very high, over 3. The highest it should ever be on a normal DPF is like 2.25. We were up at 3.58. And look at the after treatment diesel particulate filter operating state. It's constantly going into active DPF regeneration. Our soot load in the filter is being sensed as above normal. The filter was loaded. This filter had been in the truck about 1 year, about 40,000 miles. So it really shouldn't have been anywhere near that soot loaded, but there was reasons for it. So let's move on now to the road test after we replace the EGR cooler and the DPF. The first thing we're going to look at in here is, again, we're at 100% load. That means the driver's got his foot to the floor and the engine is giving it all the fuel it can. Look at our soot level on the right. And more importantly, the out-treatment diesel particulate filter operating state. You don't see regen in there once. It's running passively where it says inactive. And look over on the left at our differential pressure for the filter, and it is a maximum of 1.07. Okay, so that's very good. Last, let's take a look at the effect that the EGR cooler had on NOx. So the slightly pink on the left is before we changed the plug cooler. And the cooler wasn't completely plugged. I'd say it was probably 60% plugged. So there was some exhaust getting through it. So on the left column, we have after treatment intake NOx. So that's the NOx coming out of the exhaust manifold going into the exhaust system. And then the next column, after treatment outlet NOx corrected, that is the NOx that is what the system has been able to bring the NOx down to after it leaves the SCR brick. Now let's go to the two white blocks. The white block on the left is intake NOx corrected. That's NOx coming out of the exhaust manifold. You can see it is even a little bit lower average than what we had on the left where the cooler was plugged. And look at the outlet. The outlet NOx is all the way down to almost nothing. So the system was able to bring it way, way down because the EGR cooler was doing a better job. Overall, we had much less NOx being made in the combustion chamber because now the EGR system was working correctly. So the SCR system, dosing the same amount of SCR fluid, was able to bring those numbers way on down. So there were a number of other things in the log that I didn't show you, trying to keep this video short and trying to make sure that it's making sense to you. But the intake manifold pressure or boost went up almost 8 inches of mercury. It almost hit 70 before it was lucky to hit 55. The exhaust gas pressure came down. That came down because the ECM was raising exhaust gas pressure higher than normal, trying to flow more EGR since the EGR cooler was plugged. And then when the exhaust gas pressure goes up, it's because the turbo's choking off the exhaust. So that means you've got more back pressure when the valve's open. So you're putting less clean air in the cylinder. And then that can cause poor combustion if there's not enough oxygen in there. So then you get smoke. And our big problem has been smoke all along. Not smoke we can see, of course, but smoke going down the road, when he's stepping on it or trying to go up a hill. Now, the best part of this is when the driver says, wow, this thing runs a lot better now, you know you made a difference because he's feeling the seat of the pants driving it every day. And so possibly in the future, I'll talk more about the different things in the logs. The big important ones today, I wanted you to see that it made a difference in NOx, the EGR cooler working properly. I wanted you to know that it affected exhaust gas pressure and boost, and it will affect the amount of soot and ash, ultimately ash, that's in the DPF. I understand that ash is from oil and not oil and metal particles. It's not from soot. But when you get that filter really, really overheated all the time, those cells can break down and they can get so hot internally they melt. And so then that artificially raises the restriction, and the ECM is calculating by looking all the time at higher after treatment differential pressure. It's calculating that must be happening because there's more ash load in the filter. So because there's no way for the software to measure how much oil the engine's using or how much particles of metal are going out, and those things the ash from the oil and the metal particles can't get through that filter, so they plug it. And that's what's called ash load. So the software basically looks at the restriction. I'm guessing that it's looking at miles or hours as well. And again, they learned all this in a lab and they program it into the software. Thousands of hours of running in test cells, measuring. Then the real world stuff is put into the software, so it auto calculates it. And all it can use is the amount of fuel and time and the way the engine runs performance wise. So I hope that all makes sense. And in the future, I decided I'm going to go through all the features and parameters. I think that's important. I think it'll be surprising to you some of the things you can set and can't set. Those are probably going to start hitting the screen in June, and there may be a video like this in between. But I'm going to go through from A to Z, all the features and parameters in an X15 2450, because that'll have everything that you're going to see as of today in it. So you can look for that. That will probably burn up 2 to 3 months in terms of the amount of videos it'll take, because the first one's pretty long. It's already like 10 minutes. I'm really going to try and keep them down to under 8 minutes. If I do, then it's going to be longer, because I'm going to tell you everything you need to know about that and explain them the best that I can. So that's coming. And there's a couple other interesting things that should be popping up too. So thanks. I'll see you again next time. Have a good week. And the Shop Joe out.